1604, March 10th, 2026, right now marks 2,179 hours of progress on the global horror simulation. Today, the voxel fog of war system is finally working in the more complex HD scene, and that has been done by resolving 3 different errors within the code. Now, those appear to be most of the errors resolved, and the only real edge case left seems to be bad topology, or strange topology, because the way the algorithm works is that the level searches for all colliders and then creates a bounds around that, and then for every collider within that was discovered, it keeps track of the game object, and then it detects if the game object has a mesh filter attached to retrieve mesh data, and then that is searched, and then that object is subdivided into smaller voxel sets, and then those voxels are compared to the level voxels. And apparently it would seem that most objects are voxelated correctly, although certain areas of this object are not, which appears to be a case of possible topology issues, because the algorithm checks the triangles of the objects and then checks which voxels local to the object overlaps those triangles, and then the local voxels search for the nearest voxel within the level grid and then tag those as being necessary to be hidden. And so 3 of the bugs that were fixed today, one of them was an issue of certain objects with too little data for whatever reason, as 2 of these 3 lamps have 0 local voxels for whatever reason, and trying to create a compute buffer with that data would crash the program, or not necessarily crash the program, but stop it from compiling. And so the fix for that was just to check if a object for whatever reason has 0 local voxels before attempting to create a compute buffer and send that to a compute shader. And so those objects should still be masked, as for whatever reason the third voxel or third object has its 12 voxels on it, and so those should be masked, and it does appear that they are. And so the other issue other than that was geometry being masked at the top of the level and other areas, which was fixed and resolved. And the actual cause of that was basically there was an improvement made to the voxelization system, which was basically originally every little voxel in the level was compared to the center of voxels in every little voxel on objects was compared to voxels in the level by using the center position. But what was found was that an edge case could occur for certain objects with more complex geometry, or objects that are situated between 2 level grids at an odd angle. What would happen is that, like in this case, the center of a voxel might be there, and then the object might have geometry along the edge, and then because the center of the object was used to tag the nearest level voxel, if there's triangles outside of that level voxel, then those triangles wouldn't be hidden. And so what was used as a solution to that was basically for every single local voxel to an object, not only is the center used, but the corners are instead used instead of the center. So basically, the 8 corners of a voxel are used to calculate the nearest voxels surrounding that in the level, which allows for object to be perfectly occluded. And the solution to stopping geometry from being masked at the top of the level and other strange areas was found to be that corners, if they are along the edge of the voxel grid, can sort of cause an overflow to the top, because it tries to calculate a position for a voxel that doesn't exist within the bounds. And so that was prevented, was basically voxel positions that don't exist. And the third issue in the level, well, that's actually all of them. The first was the objects with 0 local voxels, and the second was the geometry at the top of the level. And well, actually the third was this specific object, the shadow proxy. So that specific object, for some reason, voxels were being spawned on top of it instead of directly on the object's geometry. And what was found to be the issue there was that the wrong offset was being used between voxels. And what was happening was that in order to determine the offset between voxels and to map them correctly to the geometry, the offset between voxels is calculated as being the distance between voxel 0 and voxel 1, assuming the voxels are originally calculated in a perfect square. Then that should have the distance between two, but the assumption that was made incorrectly going recently was that that value was calculated after the voxels were being filtered, and as an example, a lot of these objects, after they are being filtered to voxels that precisely overlap the geometry, there's gaps, and so the offset from 0 to 1 for this object, 0 could be all the way on the left and 1 could be all the way on the right, and so it was modified the algorithm to store the offset between the local individual voxels of every object at the start, and then use that later instead of using the offset between voxels after everything's been filtered, which is incorrect. And so the intention going forward, now that the system appears to be working for a complex scene such as this, is to look into getting it to work with height fog, and then allowing that to be dissipated and leave a trail behind and have line of sight angles and such.